Welcome, comrades perennials, to another episode of the audio podcast, Synthetic. Artificial intelligence will not replace you, but someone using artificial intelligence definitely will. We like to think that better science tools automatically mean better scientific truth.
Right.
But right now, ecology and conservation are facing this massive paradox. The better our digital telescopes and environmental sensors get, the less we actually understand how they work.
Yeah, it's a real issue.
So, we are going to look at a comprehensive analysis of a recent study published in the journal Bioscience on August 15th, 2026. As you navigate a world increasingly defined by, exponential technological growth, you might naturally assume that more data equals more illumination.
You'd think so, yeah.
But this discussion focuses on a rather unsettling reality. As cutting-edge scientific tools become exponentially more capable, the scientists actually using them are increasingly left in the dark about how they fundamentally operate. You have to imagine a scenario where the lens through which we view the natural world is incredibly sharp, but the mechanics of the telescope itself are completely hidden from the person looking through it.
And the foundation of this issue stems from research by an international team of scientists. They are observing a massive shift in methodology right now.
State-of-the-art tools are revolutionizing everything, right?
Oh, completely. We are talking about mapping global migration routes in real time, or analyzing subtle shifts in forest canopies across entire continents.
Wow.
The tools doing this, high-resolution satellite networks, expansive online data harvesting, complex digital sensors, and artificial intelligence, they are incredibly powerful, but they are increasingly operating as scientific black boxes.
And when you say black box, you mean?
I mean a system where you can clearly see the raw input and you receive this highly polished output, but the internal workings, the actual mathematical algorithms and data processing pathways are entirely opaque to the user.
So the researchers have no idea what happens in the middle.
Right. And when researchers cannot see how a tool arrives at its conclusions, it presents a severe challenge to the fundamental trust in scientific research.
I want to translate what a black box means for the actual scientific process. Imagine you are an investigative journalist, right? And you're working on the most important corruption story of your career.
Okay.
All your critical evidence documents, photographs, recorded conversations is handed to you in a tightly sealed envelope by a massive corporation.
Wow.
And this corporation explicitly refuses to explain how they gathered the evidence, who they talked to, or what methods they used to verify it. They just hand you the envelope and tell you to trust the contents.
That's a terrifying thought for a journalist.
How could you possibly verify the truth of the story you are about to publish? Applying this to the bioscience study reveals a nearly identical situation in modern ecology. Researchers constantly rely on these advanced technologies, but they are frequently locked out of the underlying algorithms.
Exactly. They are prevented from conducting direct system testing to see how the software behaves under different conditions. They are essentially handed a sealed envelope of environmental data.
So why is it locked? Who is sealing the envelope?
Well, the findings from the study's lead author, Ivan Juric of the University of Paris-Saclay, detail why this opacity exists. These tools are not hidden by accident.
They're not.
No, they are largely owned by private companies that intentionally limit access to information about how their systems process data. This restriction is driven entirely by commercial aims and proprietary constraints.
Money, basically.
Right. Tech companies invest billions in developing these systems, and they strictly protect their algorithms as intellectual property to maintain a competitive edge. Large language models and sophisticated AI technologies are prominent examples here.
Because ecologists are using those to simulate ecosystems, right?
Yeah, exactly. Let's say a researcher wants to predict how a specific invasive insect will spread through a forest over the next 10 years. They feed climate data, tree density, and historical spread rates into a proprietary AI.
And out comes a prediction.
A beautiful high-resolution heat map showing exactly where the insect will be. But the researcher cannot know how the algorithm weighed the temperature against the tree density, or if it prioritized recent data over older data.
Because it's a corporate secret.
Exactly. Because the architecture of these AI systems is protected by corporate secrecy, the scientists using them just cannot scrutinize the decision-making process.
I'm struggling to understand the scope here, though. It is easy to look at massive artificial intelligence models and accept that they are opaque. But isn't this transparency issue exclusively an AI problem?
You would think so, but no.
It feels like we're focusing on the very bleeding edge of technology, isolated to neural networks.
Well, The surprising details from the article show the issue extends much further. It penetrates the ubiquitous, everyday data tools that scientists have relied on for years. This proves the problem is systemic across scientific disciplines.
Like what? What everyday tools?
Wildlife tracking devices, for instance. They are a staple of conservation biology. Researchers attach collars or tags to animals to study migration and habitat use.
Right, that's been happening for decades.
But the study points out that the manufacturers of these devices frequently withhold the raw data collected by the sensors.
Wait, really? They withhold the raw data?
Yeah. Instead of providing the unedited numbers, the companies provide scientists only with heavily processed animal locations. The software inside the tracker or on the company's servers alters the data before the researcher ever sees it.
Let's unpack what that means in practice for a biologist. If a researcher is tracking a specific bird, the raw GPS data might show the bird suddenly darting 100 feet to the left and back again. The proprietary software inside the tracker might mathematically categorize that erratic movement as a GPS error or a satellite glitch and simply smooth the line into a perfectly straight flight path.
Exactly.
But to the biologist, that so-called glitch might actually be the bird diving to catch a very specific type of prey or evading a predator. Because the algorithm is hidden and the raw data is withheld, the biologist never even knows that vital behavioral event was erased from the record.
The observation of reality was altered by a corporate algorithm.
That is wild.
And that exact mechanism applies to remote sensing products as well. The everyday satellite images used to track deforestation or ocean temperatures rely on proprietary processing that researchers cannot access.
Because satellites don't just take normal pictures.
Right. A satellite does not simply snap a photograph like a digital camera. It gathers raw electromagnetic reflectance data. A company's algorithm takes that raw data and decides how to stitch together, how to correct for atmospheric distortion, and how to compress the file size.
So it's heavily interpreted.
Heavily. By the time a researcher is looking at a pixel on a screen representing a patch of rainforest, that pixel has been mathematically altered dozens of times by hidden commercial software.
Wow.
We also see this vulnerability in how researchers monitor human interactions with nature.
Oh, like social media.
Yeah. Search engines and social media platforms have become highly valuable resources for studying biodiversity. Scientists track public interest in conservation, map the spread of invasive species through citizen photographs, and analyze online sentiment regarding environmental policies.
But those platforms are entirely governed by hidden algorithms and shifting corporate policies.
Exactly.
I mean, those internal rules determine what information is surfaced to the top of a feed and what is suppressed. A researcher cannot know how a social media algorithm weighs a post about an invasive species from a rural area versus a post from an urban center.
And that introduces completely unquantifiable biases into the data set. The researcher is trying to measure public behavior, but they are actually just measuring the behavior of the platform's recommendation engine.
Which changes all the time.
Exactly. And this exact vulnerability extends to social surveys, which are a vital component of understanding human impacts on the environment. Scientists are increasingly relying on private, commercial companies to recruit participants and manage these surveys.
Leaving researchers completely blind to the methodology.
Right. They do not know how respondents are selected, what metrics are used to maintain data quality, or, crucially, if autonomous AI agents or bots interfered with the survey responses.
So the entire pipeline of data, from the physical location of a wild animal to human social behavior, is mediated by corporate mechanisms that refuse to reveal their internal logic.
That is the reality we're looking at.
This raises a really difficult question about the scientific community. If I'm a researcher whose entire career is based on rigorous truth-seeking, why on earth would I blindly accept data from a black box?
It's a fair question.
I mean, if I know the bird's flight path might be artificially smoothed out, or the survey data might be skewed by a hidden algorithm, why use these tools at all?
Well, the study identifies powerful environmental and academic drivers pushing scientists into this dependency. First, we are facing urgent, existential environmental crises.
Right. Rapid biodiversity loss, climate shifts.
Massive habitat destruction. Scientists are racing against the clock to understand and mitigate these disasters, and they are doing so while drowning in growing data sets that are simply impossible to analyze manually.
They just have too much data.
Yeah. They physically need the speed and massive processing power these corporate tools provide just to keep their heads above water.
Coupled with that environmental urgency is a fierce, systemic culture within the academic community itself. Scientists face immense pressure to constantly increase their productivity, secure funding, and remain competitive in their fields.
Publish or perish.
Exactly. Producing high-impact research requires analyzing massive amounts of data quickly. The sheer convenience and speed of these black box technologies offer a shortcut to productivity.
And this environment forces researchers into a difficult position where they prioritize output and efficiency over the painstaking and sometimes impossible task of algorithmic transparency.
It's a tough spot to be in.
An analysis based on insights from Professor Karen Anderson of the University of Exeter clarifies that the rush toward these tools is compounded by elements beyond commercial constraints.
What else is driving it?
The technological complexity of modern data analysis is so severe that users, and remarkably, sometimes even the developers themselves, struggle to scrutinize how the tools operate.
Let's talk about that complexity, specifically the concept of parameters in machine learning. Because when we hear that a modern AI model contains billions of parameters, what does that actually mean?
It's hard to visualize.
Right, a parameter is basically a tiny decision node, a mathematical weight. It is not a clear, human-readable line of code that says, if this, then that.
No, not at all.
It's a microscopic adjustment in a massive, multi-dimensional web of probabilities. The system learns by tweaking these billions of weights until the output matches the desired result.
And because it is just a vast sea of numbers, a human cannot simply look at the code and understand the logic.
So even if a technology corporation decided to open its doors and hand over the source code, the scientists still wouldn't be able to decipher exactly how the AI connected to specific variables.
Exactly. When a tool reaches this level of complexity, the scientist using it operates more like a consumer pressing a button than a rigorous investigator.
That's a scary thought.
The researchers in the bioscience study warn of severe consequences cascading from this reality. The immediate risk is technological monopolies, where a few private corporations control the exclusive means to generate advanced scientific knowledge,
Which directly impairs open science initiatives designed to make knowledge universally accessible.
Furthermore, relying on unverified algorithms increases susceptibility to manipulation, whether through biased training data or intentional corporate tweaking. Most critically, this trend threatens the erosion of scientific reproducibility.
And reproducibility is the absolute core of the scientific method. It is the vital mechanism where independent teams must be able to run the exact same experiment and see if they get the exact same result.
Without it, you don't really have science.
It is like trying to bake a cake using a pre-mixed batter where the ingredients are a corporate trade secret. You add water, you bake it, and if the cake comes out tasting completely wrong, you have no way to isolate which ingredient caused the problem.
That's exactly it.
More importantly, you cannot replicate the recipe in another kitchen to verify the process. If key analytical steps are hidden inside a proprietary algorithm and cannot be repeated by an independent lab, confidence in science gradually crumbles.
Which is why the study lays out specific, actionable recommendations designed to inject transparency back into the scientific method and address this crisis of reproducibility.
So what concrete steps can be taken?
The primary defense is prioritizing open-source software and open hardware whenever it is possible. By utilizing tools where the underlying digital code is publicly available, researchers ensure that every step of data processing can be audited by the global scientific community.
And open hardware.
Open hardware means the physical sensors, the circuit boards, the tracking collars, the microphones used to record wildlife are built using schematics that anyone can download and inspect.
But, proprietary tools will inevitably still be used, right? You can't just avoid them entirely.
True. In those instances, the researchers strongly recommend benchmarking proprietary tools against transparent datasets.
Benchmarking is a fascinating concept to unpack.
Yeah.
Essentially, this means feeding the black box a data set where you already know the exact answer.
Exactly.
If you have a set of environmental data that has been meticulously analyzed by human experts, you run that known data through the hidden algorithm. If the AI spits out a slightly different result, you can observe how the system altered it.
Yes. It gives scientists a way to reverse engineer the tool's hidden biases without needing access to the actual proprietary code.
That's clever.
Additionally, comparing results across multiple independent methods ensures that conclusions are not entirely reliant on a single, opaque algorithm.
Right. If you use 3 different tools and they all converge in the same answer, your confidence in the result increases.
Crucially, the study emphasizes meticulous documentation. Researchers must rigorously record the specific training data they use, the exact data pipelines and software versions employed, the precise settings chosen, and explicitly document the tool's limitations.
Basically leaving a really clear paper trail.
Yes, these steps create a detailed map of the research process, highlighting exactly where the transparent methodology ends and the black box begins. The central thesis of Michael Bertram from the Swedish University of Agricultural Sciences and Stockholm University anchors all these solutions.
Which is what?
That human oversight must remain central throughout the research process. The ease of automated analysis must never supersede human critical evaluation. Study authors, not the technology companies that built the software, must take ultimate responsibility for any errors and uncertainties produced by the tools they choose to use.
That shifts the burden of proofs back to the scientific community. If a scientist publishes a definitive conclusion based on an AI's analysis of satellite imagery, that scientist owns the flaws in that AI's logic.
They do.
They cannot just blame the black box if the data turns out to be skewed.
And this level of accountability requires an urgent call for open science regulations. We need systemic institutional frameworks that would legally improve researchers' access to digital platforms and the underlying data shaping their outputs.
But until those exist,
Until such regulations exist, scientists must remain highly alert to the trade-offs of uncritical adoption. They must consciously weigh the speed and power of a proprietary tool against the loss of methodological transparency.
they have to constantly question whether the data they are extracting is a true reflection of the natural world, or merely an artifact of an algorithm they are not allowed to see.
Precisely.
In a modern world, overflowing with complex information, the overarching lesson is that the hidden mechanisms used to gather and process data are just as consequential as the data itself. You cannot separate the observation from the instrument used to observe it.
You really can't.
If the instrument is flawed, mathematically biased, or intentionally obscured by corporate interests, the foundation of the resulting knowledge is fundamentally compromised.
Completely.
The scientific method relies entirely on the ability to trace the path from raw reality to published conclusion, and shielding any part of that path endangers the integrity of the entire endeavor.
It really does put everything at risk.
So, consider this final thought for you to explore on your own. If the trend of relying on proprietary black box technologies continues to grow, will the major scientific discoveries of the future belong to humanity, or will they simply be the intellectual property of the algorithms that generated them? Subscribe to the podcast series Nuclear Locomotive, Neural Sawdust, and Synthetic. Namaste, thank you, and good luck.